Download this code from codegive.com, link in the description below. Cs50p Lecture 6, File I/O, a deep dive. This tutorial will provide a comprehensive overview of file I/O, input/output, in Python, as covered in Cs50p, Cs50's Introduction to Programming with Python. We'll explore various aspects of working with files, including opening, reading, writing, and managing them efficiently. We'll also cover error handling, file modes, and different methods for reading and writing data. Finally, we'll look at some more advanced concepts and provide practical examples to solidify your understanding. What is file I/O? File I/O refers to the process of reading data from and writing data to files. It's essential for interacting with persistent storage and allows your programs to work with data that survives beyond the program's execution. Without file I/O, programs would only be able to process data that is input during runtime or hard-coded within the program itself, making them much less versatile. 1. Opening files. The first step in working with a file is to open it. This is done using the open function. *filename.txt, this is the name of the file you want to open. Make sure the file exists in the same directory as your Python script or provide the full path to the file. *mode, this is a string indicating how you want to interact with the file, read, write, append, etc. Common file modes *. Mode description. *. Read mode. Opens the file for reading. The file pointer is positioned at the beginning of the file. This is the default mode. *write mode. Opens the file for writing. If the file exists, it's truncated, overwritten. If it doesn't exist, it's created. *append mode. Opens the file for writing. The file pointer is positioned at the end of the file. If the file doesn't exist, it's created. *exclusive creation mode. Opens the file for exclusive creation. If the file already exists, the operation fails. *read and write mode. Opens the file for both reading and writing. The file pointer is positioned at the beginning. *read and write mode. Opens the file for both reading and writing. The file is truncated. Creates the file if it doesn't exist. *read and append mode. Opens the file for both reading and appending. The file pointer is positioned at the end of the file. Creates the file if it doesn't exist. *binary mode. Used in conjunction with other modes, example RB, WB, to work with binary files. *text mode. The default mode. Used to work with text files. Example, opening a file for reading. 2. Reading files. Once a file is opened, you can read its contents using various methods. *read, reads the entire file content as a single string. *read line, reads a single line from the file, including the new line character, \n. *read lines, reads all lines from the file and returns them as a list of strings. Example, reading the entire file. Example, reading line by line. Example, reading all lines into a list. 3. Writing to files. To write data to a file, you need to open it in write, W, or append, A, mode. *write, string, writes the specified string to the file. *writ_lines, list of strings, writes a list of strings to the file. It does not automatically add new line characters, you must include them yourself if desired. Example, writing to a file, overwrites the existing content. Example, appending to a file. Example, writing a list of strings to a file. 4. Closing files. It's crucial to close files after you're finished with them using the close method. This releases system resources and ensures that any buffered data is written to the disk. Failing to close files can lead to data corruption or resource leaks. 5. The with statement, context manager. Python provides a more convenient and safer way to handle files using the with statement. The with statement automatically closes the file when the block of code within the with statement is finished, even if errors occur. This simplifies file handling and prevents potential resource leaks. It's generally considered the best practice for file I/O. Example, reading with statement. Example, writing with statement. 6. Error handling. When working with files, it's important to handle potential errors such as file not found error, raised when the file you're trying to open doesn't exist. IO error, a more general IO error. Permission error, raised when you don't have the necessary permissions to access the file. Use try, except blocks to gracefully handle these errors. The examples above already demonstrate good error handling practices. 7. Working with binary files. When dealing with non-text files, images, audio, video, etc., you need to open the files in binary mode by adding B to the mode string, example RB for reading binary, WB for writing binary. Example, reading a binary file. Example, writing a binary file. Important note about binary data: dealing with binary data often requires specialized libraries, like the Pillow library for image manipulation, to interpret and process the data correctly. The examples above show the basic file I/O but don't handle the actual image decoding or encoding. 8. File paths, relative and absolute. Relative path *, a path relative to the current working directory of your Python script. For example, my_data.txt refers to a file in the same directory. Data/my_data.txt refers to a file in a subdirectory called data. /my_data.txt would refer to a file in the parent directory. Absolute path *, a full path that specifies the exact location of the file on your file system. For example, on Windows, c/users/yourname/documents/my_data.txt, and on Linux/Mac OS, /home/yourname/documents/my_data.txt. Using absolute paths can make your code less portable, as the paths will be different on different systems. Relative paths are generally preferred for projects where the directory structure is consistent across different environments. Example, using relative and absolute paths. 9. Flushing the buffer. When you write to a file, the data might not be immediately written to the disk. Instead, it's often stored in a buffer. You can force the data to be written to the disk by calling the flush method. This is useful when you need to ensure that data is written immediately, example for critical logging. The with statement generally takes care of flushing when the block exits. 10. Reading and writing specific data types, serialization. Sometimes you want to read or write more complex data structures, lists, dictionaries, objects, to a file. You can't directly write these structures to a file as strings. You need to serialize them, convert them into a string or byte stream, before writing, and deserialize them, convert them back into the original data structure, when reading. Two common modules for serialization are *JSON, for working with JSON, JavaScript object notation, data, which is a human-readable format. *pickle, for serializing Python objects. *warning, only unpickle data you trust. Unpickling data from untrusted sources can execute arbitrary code. Example, using JSON. Example, using pickle. 11. Working with CSV files, comma-separated values. CSV files are a common format for storing tabular data. Python provides the CSV module to make it easy to read and write CSV files. Example, writing to a CSV file. Example, reading from a CSV file. 12. Using different delimiters in CSV files. CSV files don't always use commas as delimiters. Sometimes they use tabs, \t, semicolons, or other characters. You can specify the delimiter when creating the CSV.reader or CSV.writer. Example, using a tab delimiter. Key takeaways *. Always close files after you're done with them, or use the with statement. * Use try, except blocks to handle potential errors. * Choose the appropriate file mode based on whether you want to read, write, or append. * Use the with statement for cleaner and safer file handling. * Understand the difference between text and binary files and use the B mode for binary files. * Use the JSON or pickle modules to serialize and deserialize complex data structures. * Utilize the CSV module for efficiently working with CSV files. This tutorial provides a solid foundation for understanding and using file I/O in Python. Practice these examples and explore more advanced features of the OS, JSON, pickle, and CSV modules to further expand your knowledge. Remember to always handle files responsibly and be mindful of potential errors. Good luck.